tower down to the ground. Betsy, I know what you can do. What? Well, you see, the clock tower forms a 90-degree angle with the ground, so we can figure out how many lights we need with some simple calculations. Cool, thanks, Lydia.
I found the perfect Christmas tree for the Student Center, but SGA says it has to be less than 20 feet tall. Is this less than 20 feet tall? I don't know.
I know how you can figure it out, Kristen.
Really, Lydia? What do I do?
Well, since the tree forms a 90-degree angle with the ground, we can use some simple calculations to find out how tall it is.
Wow, how do I do that?
Let's get started. I'll show you.
Learning about trigonometry will help us to solve these problems. Trigonometry simply means triangle measurement. Specifically, today, we will learn about right-angle trigonometry. We will learn if the triangle has a right angle, which is 90 degrees, that we will be able to use these methods. Let's learn the lingo that will help us to solve the problems with right triangles. First, as you hopefully remember, across from the right angle is the side which we call the hypotenuse. We will label the hypotenuse H. The other two sides, or the legs, are named according to an identified angle other than the right triangle. We will call this angle theta. The side adjacent, or touching the angle theta, is called the adjacent side, which we will call A. And finally, the side across from the angle is called the opposite side. We will call it O. Let's review. The side next to the labeled angle theta is called the adjacent side. The side across from the angle is called the opposite side. And the side across from the right angle is called the hypotenuse. Based on what we know, we can solve for all unknown sides and angles using these trigonometric ratios. So, to start, we will talk about sine. The sine of theta, which is written as sine theta, it looks like sin, but it's pronounced sine, and it's the ratio of the opposite side over the hypotenuse. So this is the opposite side, and that is over the hypotenuse. Or we can simplify it and just write it as O over H. Similarly, the cosine of theta, written as cos theta, is the ratio of the adjacent side over the hypotenuse, or A over H. And finally, the tangent of theta, written as tan theta, is the ratio of the opposite side over the adjacent side, or O over A. Now, you might be saying to yourself, how in the world can I remember these ratios and keep them straight? It's simple. We have a mnemonic device that we use to remember this, called SOHCAHTOA. Say it with me, class. SOHCAHTOA. Very good. Now, what does this mean? Simple. It means that sine is equal to the ratio of the opposite over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse. And tangent is equal to opposite over adjacent. And so we have SOHCAHTOA. Say it with me one more time. SOHCAHTOA. Awesome. Now we're going to transition over to Betsy, and Betsy's going to tell us what she's learned about how to figure out how to decorate the clock tower.
First, we need to measure how far away the end on the ground will be from the clock tower.
Jingle bell rock, jingle bells swing and jingle bells ring, snowing and blowing and bushels of fun. Now the jingle hop has begun.
Next, we're going to use the altitude finder so that we can know the angle from here to the top of the clock tower. going to pull the trigger and let it find the angle. And our angle is 33 degrees. In order to figure out how many lights we need to decorate the clock tower, we are going to start out with the cosine function. Cosine is the adjacent side over the hypotenuse. So cosine of 33 equals 100 feet over our hypotenuse, which is our unknown. First, to solve for the hypotenuse, we're going to times both sides by h. So we end up with h cosine 33 equals 100. In order to get h by itself, we are going to divide by cosine of 33. So we're left with h equals 100 divided by the cosine of 33, which is 119.2 feet. Next, in order to solve for the height of the clock tower, we are going to use the sine function, which is the opposite side over the hypotenuse side. So we set up our equation as a sine of 33 degrees equals the opposite over 119.2 feet. Then we're going to multiply both sides by 119.2, and then we're going to solve for O, which is 64.9 feet, but this is not our total height for the clock tower. We need to add that to the height of the person looking at the tower, which is 5.5, resulting in a total of 70.4 feet. We have anchored the measuring tape to the base of the tree, so we're going to see how far away.
Jingle bell, jingle bell, jingle bell rock. Jingle bells chime in jingle bell time. Dancing and prancing in Jingle Bell Square. In the frosty air.
Now it's your turn to use the altitude finder. We're going to figure out the angle from your eyes to the very top of the tree.
Wow, it's 22 degrees.
Perfect! Next, in order to find out if our Christmas tree can fit in the student center, we are going to use the tangent function. Tangent is the opposite side over the adjacent side, which is 48.75 feet. To solve for O, we need to times both sides by 48.75 feet. And our answer is 19.7. But we must add that to 5 feet, which is the height of our person, which gives us a total of 24.7 feet, meaning our Christmas tree is too tall to fit in the student center, so we must go out and search for another one.